Hey guys, we are on day 2 of Unit 2, and we'll be multiplying and dividing rational expressions today. All right, cool thing is the dividing ones turn into multiplying with a keep changed flip, if you remember that. So if you pay attention during the multiplying ones, the dividing ones aren't that bad on the back. All right, so procedure for multiplying expressions with monomials. You're going to multiply the numerators and write what is left on top of the fraction. You're going to multiply the denominators and write what is left on the bottom of the fraction. And then we're going to reduce the resulting single fraction, if possible, to lowest terms. All right. You can also do something called cross-reducing. If you can reduce along the diagonal crosses, that is also allowable. All right. But I find that it's easier to follow these steps. So remember that when you guys are multiplying two fractions together, you go across the top and you go across the bottom and you get your answer. All right. Some people think that you can cross multiply two fractions. That is only when you have a fraction equal to a fraction. That's when you can cross multiply. Okay. So don't get confused. All right. So number one, when we go across the top, we multiply our coefficients, we get 80. X squared, y to the 7th would be our variables. Across the bottom, our coefficients would multiply to 30, x cubed, y cubed. And then we're going to do step 3 where we reduce. All right. If you don't know how to reduce 80 divided by 30 by finding the largest number and dividing them both, you can always go ahead and use your calculator. If you type in 80 divided by 30, you might get a decimal. And then if you math frac it, then it will spit out to you 8/3, right? So basically 80 divided by 10 turns into an 8, 30 divided by 10 turns into a 3, and that is 8/3. That's the lowest, all right? With variables, we subtract the exponents, or you can think about what the difference between the exponents is. Difference is also subtraction. And then wherever the higher exponent is, that is where your x's are left. All right. So with x squared and x cubed, if I take and I cross out x squared here, I could take an x squared out of x cubed, but there will be an x left over. All right. Same thing with y to the 7th and y cubed. These y cubed taking out of y to the 7th would leave y to the 4th up at the top. Okay, and so the only thing I have left after I reduce is the 8y to the 4th on the top and the 3x on the bottom. There's nothing left to reduce. We're going to box that up, and that's our answer for multiplying those two fractions together. Okay, next one up, you guys can see that it's very similar. You have a monomial fraction times another monomial fraction, and all we have to do is go across the tops and across the bottom since our operation is multiplication. And we're going to get an answer. Okay? Up at the top, 6 times 10 is 60. I do have an x squared here and an x here, and when we multiply them, we add the exponents, don't forget. And remember, the exponent here is 1, so that'd be x cubed. And y to the 3 plus 2 is 5. On the bottom, 4 times 9 is 36. We get x to the 10th and y to the 7, 8, 9, 9th. Okay. We could use our calculator to reduce our fraction if we don't feel like finding the largest number that goes into it. All right, the largest number that does go into it seems to be 12. Okay, 12 goes into 60 5 times, and 12 goes into 36 3 times, and that's why my calculator spit out 5/3 as the reduced fraction. Okay, if we take the 3 x's from the top and cancel them with 3 out of the 10 x's on the bottom, we'll have x to the 7th left over. Y to the 5th will be completely gone, and y to the 5th taken out of y to the 9th will leave y to the 4th. Okay, I believe that is all I can cancel, so going across the top, I only have a 5 left. Across the bottom, I have a 3, x to the 7th, y to the 4th. And there is our final answer in reduced form. Okay, so hopefully that wasn't too hard. And now we're going to go and do a procedure for multiplying binomials and trinomials. Okay, we'll move this up. So you're going to see that in these questions, they aren't just single terms. Okay, in fact, in number 3, We still have a monomial on top, but on the bottom of that first fraction, that's a binomial, okay? In the second fraction, the top is a binomial and the bottom is a monomial, okay? So what we have to do with binomials and trinomials and polynomials that have 4 terms, all right, we have to, as our first step, factor all expressions if necessary. Okay? Cool thing is, remember, monomials are not factorable, okay? We are going to go ahead and simplify or reduce. Common factors, okay? Not common terms, okay? You cannot reduce common terms. They have to be factors, okay? Remember, factors have multiplication in between them. Terms have addition or subtraction in between them, okay? Also, remember, anything on top can reduce with something on the bottom. Okay? Once we are done with factoring and simplifying, we'll just go ahead and multiply the numerators and write what is left on the top, just like we did with the monomials. We'll multiply the denominators and write what is left on the bottom. And we are going to make sure that we reduce the resulting single fraction, if possible, to lowest terms. All right, so here's what it's going to look like. So in number 3, because we have some binomials in this one, we have to make sure that they're factored, okay? So the 3x to the 4th on top here is not going to change, so we can keep it 3x to the 4th. On the bottom here, though, that is a binomial, and it is factorable. And the type of factoring that works on that one is greatest common factor, so we're going to go ahead and pull out a 6. We're going to be left with the 4, so that gives me the 24, minus the x to the 4th. However, I have good math eyes, and I can see that this is a D2PS, and so the 6 will drop down, and I'm going to factor my D2PS into 2 plus x squared and 2 minus x squared. None of those factors can go again, and all I'm going to do is draw one line through that so I know that it has been transformed into this, but I'm also going to put a line through that because that's been transformed, okay? So I don't want you to think that those are left. All right. At the top here, we have another greatest common factor, and that is a 5. If we pull it out, we're left with an x squared plus 2, and that can't go again, and so I'm just going to replace that with its factored form. Okay? Remember, if I'm grading your paper, I still have to read your work that you're crossing out, and that's why I only use a single line through mine. Okay? Some people use highlighters so you can still read what's underneath. All right, so now we're going to do something called cross-reducing. Okay? We cross-reduce here, but not so much with the monomials, although you could. All right. So the very first thing I like to look for is common factors. So right here, I have a 2 plus x squared. All right. I'm just going to highlight it so you can see what I'm talking about. This is a 2 plus x squared, and this is an x squared plus 2. Both 2's are positive, both x squares are positive, and so these are exactly the same thing. And so they reduce to 1. Okay, so something on top reduces with something on the bottom. Some people will say that they cancel. Technically, when you say cancel, I think 0. All right. Technically, x squared plus 2 divided by 2 plus x squared is a positive 1. All right. So we say that they reduce. I don't see any other of the same factors. So now I'm going to start looking for monomials. So the first thing I see is I have a 3 on top and a 6 on the bottom. And I know 3 goes into 3 once, and I know 3 goes into 6 twice. Okay. I also see a 5 and a 25, and the 5 goes into 5 once, and the 5 goes into 25 5 times. Okay. I don't know. Oh, I got one more thing. Okay. See this x here? And the x to the 4th, we can cross-reduce it. So this x will be gone, and this x to the 4th will turn into x to the 3rd. Okay, so it looks pretty sloppy with what's left over. So sometimes I'll highlight it so I can see. So I don't really need to highlight those ones because I have something else here, which is x cubed. And it seems to me everything else is gone. Okay, and so I only have an x cubed on top. On the bottom, we'll highlight what's left. The 6 there turned into the 2, which is still left. That factor's gone. This is still left. And my 5 is still left, but the x is gone. And I'm going to go ahead and multiply those two numbers, that 2 times the 5, and get a 10. And the one factor that I highlighted there, which is 2 minus x squared. Nothing else will cancel or reduce, and so this one's finished. Okay, number 4. Up at the top, that looks like a hard trinomial. However, I think I can pull a 5 out and turn it into a nice easy trinomial. Okay, so we're going to pull a 5 out, and I'll be left with an x squared minus x minus 12. However, then that's a nice easy trinomial, so I'm going to put my x box over here. I'm going to multiply to negative 12. I'm going to add to negative 1, and my numbers are going to have to be negative 4 and 3, right? Okay. So now I'm going to go ahead and bring that 5 down. I'm going to go ahead and factor my easy trinomial into x minus 4 and x plus 3, and that top has been factored, okay? So this is gone and this is gone. It's turned into that. All right, on the bottom there, that's a D2PS. I'm going to factor it into 5 plus x and 5 minus x. Okay, so that's gone. We're going to keep the multiplication dot. And we have another easy trinomial, so we can set up another x box over here. Okay. We're going to multiply to negative 10, and we're going to add to negative 3. And the numbers that do the job this time are negative 5 and 2. Okay. And so that easy trinomial is going to turn into x minus 5 and x plus 2. And that one's done. On the bottom there, that is actually not factorable. It looks like a D2PS, but your x has an odd exponent on it, and it's not. Okay. We'll go ahead and we're going to look for common factors. Hopefully you guys see the x minus 4s here. One on top, one on bottom. They reduce to 1. Okay. What else do we have? All right, so we got to be pretty careful with these. A lot of people say those are exactly the same, but if you take a look at your 5s, one 5's positive, one 5's negative. Sorry. So these two factors are actually opposites. If you look at both 5's, one 5's positive, one 5's negative. So those are opposites of each other. The x is negative. Here, the x is positive, so those are opposites. And so when they are opposites, you have to remember from day 1, they reduce to a negative 1. So we're allowed to go ahead and cross them out, but we have to leave a negative 1 behind. And when there's other things, I usually just leave a negative. Okay, so for instance, that negative up on top with the 5 is really negative 1 times 5. All right, if we look for anything else that we could possibly reduce, it doesn't look like I have anything left. So I'm just going to go ahead and highlight what I have left, which is the negative 1 and the 5, which really makes it just a negative 5, the x plus 3, the x plus 2, and then on the bottom we have the 5 plus x. Okay? So we'll go ahead and go across the top. We have a negative 5, an x plus 3, an x plus 2. On the bottom, we have the 5 plus x, and that is it. Nothing else can get reduced, okay, or be reduced. All right, last one on this side. Move this up. And take a look, we have binomials and trinomials again. And so remember, the first step is to factor them if possible. And up on the top of the first fraction, that is a D2PS. And so we're going to go ahead and factor it into 3 plus x and 3 minus x. That one's gone. Okay. On the bottom, we have a greatest common factor of 2x squared. Left over would be an x minus 3. That's gone. Keep your multiplication. And up at the top, we have another greatest common factor of 4x. We'll pull that out and be left with x minus 1. And that's gone. And on the bottom, we have a easy trinomial. Okay, we are happy. Our multiply is negative 3, and our add is positive 2. And we're going to find the numbers to be 3 and 1, except the 1 has to be negative in order for us to get a positive 2 when we add them. Okay, works in the multiply. And again, remember, he's a nice easy trinomial, so we can come right to our factors of x plus 3 and x minus 1. All right, so now we're ready to go ahead and look for our common factors. And I see the x minus 1's match identical, one on top and one on bottom, and they're gone. Okay? They reduce to 1. The next thing I see is the 3 plus x and the x plus 3. Remember, both x's are positive, both 3's are positive, so even though these look different, they still reduce to 1, and we can eliminate them. Okay? And last but not least, I see a 3 minus x and an x minus 3, and this is the one where they're opposites. This 3 is positive, this 3 is negative, this x is negative, this x is positive. So both terms are opposite signs, and so remember, just like in number 4, they will reduce to a negative 1, so I just have to leave a negative behind. Okay. All right, the last thing I see some monomials, okay? I see the 2 and the 4. So remember, numbers go with numbers and letters go with letters. So the 2 goes into 2 once, and the 2 goes into 4 twice. Okay? This x here next to the 4 will be completely gone, and it will reduce with one of the x's from the x squared, leaving an x left. Okay? I don't think that there's anything left over that can be reduced. So I'm just going to highlight what's on top. I have the negative. I have the 2, and that's it. On the bottom, I don't need to highlight that 1 because I have an x here, and a 1x is the same thing as x, and that's it. And so when I write what's left over, it's only going to be a negative 2 on the top and the x on the bottom, and that is my final answer. Okay. All right, guys, I'll see you on the back side of notes.